Hi everyone, my name is Marcel and I'm working as a DevOps manager at Avanade. I hope you're enjoying the festive season and enjoying the festive tech calendar and all the great content that's being made by the community. My talk today is going to be around how to automate password rotation using GitHub Actions. And just on a side note, all the snippets of code and the demo that I'll be showing you today is available on my GitHub, and there is also a blog of this talk published on my Dev2, which the links have been shared at the beginning of the video and will be shared again at the end of the video. And feel free to come and ask me any questions on Twitter, and I hope you'll enjoy the video. So let's jump straight into it. First of all, let's talk about the what and the why about what is password rotation. So password rotation is basically a practice where changing passwords frequently or resetting passwords to basically limit their lifespan, which reduces the effectiveness of attacks. Changing passwords on a very frequent basis also limits the time frame and validity of a password if it's stolen. So say, for example, an attacker compromises a password. If the passwords are rotated very frequently, it just limits the time frame that the attacker has in using that password. Passwords should always be unique. They should never be reused and should always be randomized. But let's talk about some of the challenges and risks that comes with password rotation. If passwords are rotated very frequently and are randomized and are, say, for example, hundreds of passwords are being changed manually, this can become problematic where due to human nature, people don't remember complicated passwords of random strings or random numbers and random special characters. And if those are changing very frequently on a weekly basis, what could happen is people who use those passwords could start writing them down on a note or making a note of them somewhere, which is a great risk, which poses an even bigger risk. Another issue with changing passwords manually is it's not very scalable if it's done manually, and it can cause a lot of admin overhead. Say, for example, you have 100 servers and you have to change the local administrator password for all 100 servers every week. You will spend a lot of your time just changing passwords all day, every day. Also, manually changing passwords make them a little bit more prone to being reused or not be as randomized. So an example of that is, for example, say an administrator uses a password like his or her favorite actor or actress's name followed by a number. The next password might be the same actor or actress's name but followed with a different number. So this gives an attacker some leverage to be able to guess passwords based on your pattern. So passwords should always be randomized. Now, how can we solve this problem? Well, the problem can be solved through automation. Automating password rotation can alleviate administrative overhead. It can also be rotated much more frequently, almost on a daily basis if we really need to, and is highly scalable. Using a secure vault, for example, such as an Azure Key Vault, you can store your secrets safely and give access to those secrets only to those who need them. Password rotation can also be automated really easily using GitHub Actions, and I'm going to show you today exactly how to do that using GitHub Actions. So without further ado, let's jump straight into the demo. So over here, I've got a virtual machine, which I'm going to talk through how I'm going to set up my automation. For this demo, what we're going to do is we're going to set up a key vault, and we are going to create a GitHub action that is going to automatically rotate our local administrator password for all our servers that we have in Azure. And securely store those secrets in the key vault. Also, this technique is not limited to just VMs. I'm going to show you how to do this with VMs, but you can also apply this technique to almost anything that you want to rotate a password for. What we're going to do is we're going to set up an Azure Key Vault, and then we're going to set up a service principal that we are going to link to our GitHub action. Our GitHub action will then connect to our Key Vault. Our Key Vault will have all our servers that we have will have a corresponding key in the Key Vault. So what our action is going to essentially do is connect to the Key Vault and look at all the secrets we have, all the keys, and each key will represent a server. What the action will then do is generate a random password and then try and connect to the server which is associated with its key. If it can connect successfully, it will then set a randomized password and then save that password against the server key in the Key Vault. This way, our GitHub action can be set on a schedule that will run through all our servers and always randomize and change the local administrator password and record those secrets in our Key Vault. And we can then give access to the Key Vault to admins and people who only need access when they need to access a server through its local administrator login. So let's get started. I have here a PowerShell script that is just going to set up some prereqs for me for setting up all this automation. First of all, you need to log into Azure and select the subscription. All we're going to do here is build a Key Vault and a service principal. So firstly, I'll set some variables. I'm going to create a resource group called Festive Demo, and then I'm going to create a Key Vault called VM Password Vault 05. I'm going to create an app, which is going to be my service principal, called GitHub Secrets User 01. And this is going to be the service account, you could say, that I'm going to use to trigger my GitHub action. I am going to also use the location UK South for all my resources. So if I run that, next I am going to create the resource group and the Key Vault. If you have noticed, I am using the enable RBAC authorization parameter when I'm creating the Key Vault. The reason I use this this method is there's two ways that we can give access to a Key Vault. We can give access to a Key Vault through access policies, or a new modern way is to do it through RBAC. I like the RBAC method because it ties in very nicely with how everything else in Azure can be permissioned and granted access through role-based access control. So let's take a look and see whether that has created successfully. You can also see here I've got a couple of VMs, demo VMs. They're all stopped at the moment. I've got PWD VM 01, 02, and 03. I'll just go ahead and start 01 here for a moment. I'm just going to start that VM, and I'm going to start 02, and I'm going to start that VM. Now let's see if our resource group was created, and I can see it is here indeed, Festive Demo. And I can also see that our Key Vault was created, VM Password Vault 05. Excellent. So let's jump back to the script here. Next, we're going to create the Azure AD app that is going to be acting as our service account, you could say, that we're going to link to our GitHub action in a bit later on in this video. So I'm going to create that app. Next, we're going to get the ID of the app that we just created. And we're also going to get the subscription ID for our subscription. Now, the next step is where we're actually creating the service principal. we're going to create a service principal from the app that we just created. And then we're going to give the role-based access control of Key Vault Secrets Officer onto our Key Vault that we just created. And the reason we want to give our service principal Key Vault Secrets Officer is because our GitHub action will connect to this Key Vault in order to retrieve all the server names, which will be the keys, and then essentially generate passwords randomly for all our servers, which is going to be the local administrator password for the service. But we need this service principal and we need this permission. So I'm going to run this. What this is also going to do is it's going to generate a JSON body of the service principal, client ID, secret, subscription, tenant ID, and a couple of other things that we're going to need to link our GitHub action with this service principal. So I'm just going to make a note of this JSON body, although I only need the first 4 elements of this body. So I'm going to take out all that. We only need the client ID, the client secret, the subscription ID, and the tenant ID. Now it's important that you always keep your secrets safe. And when we are talking, when we're going to set up the GitHub action, I'll show you where this will be stored. So with that taken care of, we need to assign our service principal another permission, and we are going to give the principal access to our entire subscription as a virtual machine contributor. So I am just going to take the client ID of the service principal, and I'm going to run the additional role assignment, which is going to add the RBAC role of our service principal onto our subscription as a virtual machine contributor. Now, my scope is at the subscription level. If you don't want to have the service principal have access over the entire subscription, say for example you have all your servers in a resource group, or you only want to rotate the passwords for certain servers and those servers are all contained within a resource group, you could assign this role assignment to a resource group level rather than the whole subscription. In my case, I don't really mind, so I'm just going to set the role, RBAC role on the entire subscription. So let's take a quick look at our Key Vault permissions. If I look at my Key Vault permissions now, RBAC on this resource, I will see here that my service principal is a Key Vault Secrets Officer, and also at the subscription layer, the same principal will have VM contributor access over all the VMs in my subscription. Now, if you remember, I have 3 VMs here. I have PWD 9000 VM 01 to 03. 2 of them should be running by now, and I can see the top 2 are running. The third one is still stopped. Now, the next step that we need to do is populate our Key Vault with our server names. So I am going to take the first server name here, and I am going to go to my Key Vault. I also need to make sure that I have access to the Key Vault. So let me just quickly add myself as a Key Vault administrator. And I am going to review and give myself access to this Key Vault so that I can set up the Key Vault with the relevant server names. Now, the next thing I need to do is create a secret. So I am going to create PWD VM 9000 VM 01, and that's going to be my first server. Now, for the secret value, I could just type a random string here. It doesn't matter because our GitHub action we're going to set up is going to change this for me. So I'm going to create the first server secret. I am going to create the second server secret and the third server secret. And these are all just random passwords that I'm putting in here. I'm also going to do a fourth. I actually had a fourth server which I deleted earlier before this recording. So you can see here I've got 3 VMs. At the moment the first 2 is running, the last one isn't. But I actually had a 4th VM which I deleted. So now that we have all our prereqs and our key vault ready, we'll jump to the next section, which is going to be the automation part using GitHub Actions. Now, in my GitHub repository, I actually have a template, which is like a blueprint. I don't know if which of you have used GitHub templates before. It's brilliant, but basically you could come to my GitHub page and you can create your own repo based on my template or my repo. That if you visit my GitHub page, which the link was shared at the beginning of the video, you'll be able to find this repository called Azure VM Password Management. And all you would need to do is click on use this template. I'm going to set up a new repository based on the blueprint of that template. And I'm going to call it Festive PWD Rotate. And the description, I'm just going to say used to rotate VM passwords in Azure. I'm going to make this repository private because obviously I don't want to expose this repository to the public internet or anything like that. So it's going to be a private repository that is just linked to my organization or my Azure subscription, because I want to just automate using GitHub Actions the VM password rotation in my subscription. So I'm going to create that repository from a template. And when we look at the Festive PWD Rotate repository, you'll see here that we only have a README file, a license file, a gitignore file, and a path called GitHub/workflows. And then we've got a YAML file in here called rotate VM passwords. Now, for those of you who use Azure DevOps and is familiar with Azure DevOps multi-stage YAML pipelines, you will love GitHub Actions. GitHub Actions is very similar to the multi-stage YAML pipelines used in Azure DevOps. It also has a YAML schema, which is very similar to the DevOps pipeline YAML schema. So if you're used to writing Azure DevOps pipelines, you will feel very comfortable writing GitHub Actions because they share a very similar sort of schema. And both the Azure DevOps YAML schema as well as the GitHub YAML schema for GitHub Actions are very well documented in the GitHub documentation, as is the Azure DevOps multi-stage YAML pipeline schema is also very well documented in Microsoft Docs. But let's take a quick look at this YAML file, and you will notice that it looks a lot like a multi-stage YAML pipeline in Azure DevOps. We have a name for our action. We also have a trigger. Now, this action will be triggered. The workflow dispatch allows us to trigger this action manually. And then we also have a cron job. Now, this cron job basically means that this action will run on the first day of every week, which is every Monday at 9 a.m. in the morning. So our automation or this action workflow will just trigger every Monday morning at 9 a.m. Or we can manually trigger it. It will run on a runner in Azure DevOps. This is also what you would call your hosted agents or your Azure pipeline agent or build agent. So in GitHub Actions, these are what is known as runners. So this is going to run on a Windows image. And you'll see here that we've got an environment variable called key vault name. And we'll change this in a moment. We also have some steps where it's going to check out the repository. It's going to then connect to Azure using an Azure credential, which we're going to set up in a moment. It's then going to create a random character set. And the next step after that is it's going to connect to our key vault. So our pipeline, or GitHub action in this case, is going to connect to our Azure subscription in this step. And because the service principal will have access to the key vault, it's going to go through the key vault and it's going to look at all the keys in the key vault, which is going to be our server names. And it's going to loop through each key and it's going to say, go and find the VM that the key is matching for. If the VM is found, it's going to check, is the VM running or is it deallocated? If it is running, it is going to set a password, or it's going to attempt to set the password on the VM. It's going to change the local administrator password. It's going to generate the password first, and then it's going to set it. Once it's set it successfully, it will update the key vault secret with the new password. If the server is not running, it is going to be skipped. And if the server doesn't exist, it's just, or cannot be found, it's just going to say the VM can't be found because either the principal doesn't have access, maybe you scoped it to a resource group and your key vault contains the server name of a server that's in a different resource group or something like that. But either way, it will say, I cannot find this VM. Now, a couple of things that we need to do before we can run this workflow is going back to the repository, we have to first enable our action to be connecting to Azure. Now in Azure DevOps, we would set up what's called a service connection. Now in GitHub, we will go to settings and then we will go to secrets. In secrets, we will create a new repository secret. And in this repository secret, we will type in Azure_credentials. What we will then do is that JSON block that we captured earlier, we will save this JSON value in the Azure credentials secret. So we see here we've got our client ID, which is our service principal. We've got its secret, we've got its subscription and tenant. We're going to save that. Now you can see here we've got an environment variable called Azure credentials. Just going back to our workflow, you will see that when we are connecting to Azure, it's going to use secrets.azure credentials. And this is how we are connecting into Azure. So very similarly in Azure DevOps, we would use a service connection. This would be our service connection, you could say, from GitHub Actions into Azure. So pretty simple. Now, for those of you who, here is an extra tip which I really love. Without me having to clone this repo, I can just press the, let me just open this in a new tab here real quick. When I'm at the root of my repo, I could just press the dot button on my keyboard and look what happens here. GitHub will actually open an instance of Visual Studio Code in my browser. I do not have to have Visual Studio Code installed on my development machine. It's all happening in the browser. I don't know, for you who have used GitHub Codespaces, works very similar. It is very, very amazing, and hands up to GitHub for this amazing feature. So I can actually now go in and amend or make changes to my repo source code directly from my browser by running VS Code in my browser. So the only change that we need to do is, obviously we can change the README because that's from the template, so I can add my own README text in, because this is a new repository. But the only significant change that we would need to do on this action is just change the environment variable for the key vault name. Now, what we have used for the key vault name in our case is going to be VM password vault 05. So I'm just going to change that, and everything else will be the same. Everything else will stay the same. So I'm just going to save this, and I'm going to say created new repo, added my key vault, and I'm going to commit that. Awesome. Now, if we look at the GitHub workflow, we can see in the YAML file that it is in fact using my key vault, and you'll see here that it's using an environment variable, which is the key vault name. Excellent. So we are almost good to go. So because this workflow is already in .github/workflows, if I now go to GitHub Actions, I can see my action here, update Azure VM passwords. Now, remember, I have my first two VMs started. My third VM is stopped. In my key vault, I have VM1. I have each of the VM's server names in my key vault. So let's run this workflow and see what happens. Just on a side note, I just wanted to show you a little bit more on what exactly is happening when we are generating a password. Basically, we are going to create a random character set. And a random character set is going to be just a very long string of random numbers and letters and special characters. And that will be different each time. So we're going to create a random character set. And then from that random character set, we are going to randomize it again. So we're doing like double randomization to generate our unique password. So our password will come out looking something like that. So if we run that every time there, we will get a random password. So this is what's happening in our GitHub action when it's generating a random password. But let's quickly jump back to the GitHub action and see what is happening. So we can see that the code is checked out. So it's found server 1, and it's checking if the state of the VM. Next, it's found that the VM is in fact running, so it's now generating a new secure password, which is going to be the local administrator password, and it's updating the key vault with that new password for that VM. So now it's going to update the VM, and it says to me that the VM password was changed successfully. The second key in our key vault is VM02, and you can see here that it's found the server, and it's going to check its state, and it sees that it's in a running state. Now it's generating the password and it's setting the password. Now, remember our VM3, that VM was in fact not running, and VM4 doesn't exist. So how does our action, what does our action do with VMs that it configures? So it found VM3, but it says warning that the VM is not in a running state, so it's going to be skipped. So when the VM is not running, it doesn't change the password. Similarly, if a VM cannot be found, it would say that warning that the VM isn't found. So I know that I decommissioned the server, so I don't really need its value anymore in the key vault. So I'm just going to go and delete this key because I no longer need it. This workflow will run every Monday at 9 a.m. in the morning, and it would change all my passwords for all my VMs. Now let's test this. Let's test this out. Let's see if I can connect to VM 01 using its new password. Say, for example, an admin comes to me and says, I need to connect to VM 01. Can you please give me access to the key vault? And I would give the admin access as a reader to the key vault, which contains all the server names, maybe temporary access, maybe they're a permanent security team that needs access to the secrets all the time. Who knows what the use case might be. I would now just give the user access to the key vault to get secrets. So let's try this out. If I open a remote desktop session for VM 01, let's get the secret from the key vault. We can have a look here and see that's the secret value there. Let's see if that secret works. And it looks like it is. And there we go. I can get into my VM. That's all there is to it. Now, if you need to go and change the schedule at which the GitHub action runs, you could just go to the cron job that we set up. And remember, the cron job that we set will run every Monday morning at 9 a.m. But you can change the schedule to whatever you want. You can even have a daily schedule if you really want. And remember, the passwords will always be saved in a secure vault, which is going to be the Azure key vault. So if anyone ever needed any access to VM passwords, you could manage and maintain that through access on the key vault. And with that, I hope you enjoyed this video and learned something new. All of the code I used here is available on my GitHub page, and feel free to come on Twitter and ask me any questions if you have any. I hope you have a wonderful festive season and enjoy the holidays. Thank you for watching.